Hello everyone, welcome to C Advanced. Today we are diving into one of the most powerful and fascinating features of C, the pointers, specifically double pointers and their use cases. By the end of this video, you will understand what double pointers are, how they work, and where they are useful. Let's get started. Before we jump to double pointers, let's briefly recap what's pointer. A pointer is a variable that stores the address of another variable. So the syntax is we have a pointer star p that stores the address of var. So this ampersand sign usually means that this variable, this pointer is going to store the address of the variable called var. Now, why stop at a single level? In some scenarios, we may need a pointer that points to another pointer. Double pointers or pointers to pointers are variables that store the address of another pointer. We can declare a double pointer with uh, the data type. For example, I have taken integer here. So we can take this syntax integer star star pp. Here I have declared an integer double pointer star star pp. Let's take an example. Here I have declared a variable var with value 10. I have declared a pointer star p that uh, that is assigned to the address of the variable var. Ampersand is the address, as you know. Now I have again declared a double pointer star star pp with the address of the single pointer star p. So I have given star star pp is equal to ampersand p. Here I have assigned star star pp with the address of the single pointer. Now, if I print the value of the variable var, I'll get the answer as 10. Similarly, if I print the value of the variable star p by putting printf uh, ampersand b star p, we'll get the value 10 again. But if I print the value of star p with the percentage p and comma p. So if I print the value of p, I'll get the address of var. And if I print the value of pp, I'll get the address of star p. So basically, star star pp stores the address of star p, and star p stores the address of var. So that's how it works. The chain of interaction allows us to work with dynamically allocated memory or manipulated arrays flexibly. We'll explore the use cases shortly. When you use functions like malloc, a double pointer is often required. For example, in this function, we are dynamically allocating an array of memory to this double pointer ptr. When you allocate the memory dynamically, be sure to free up the memory by using free function to avoid memory leakage. Double pointers also help in handling dynamic multi-dimensional arrays. Stay tuned, we'll cover this in detail later. This snippet of code illustrates the working of pointers and double pointers in detail. So in this code, we have declared a variable x and assigned it with the value 10. Then we declared a pointer star ptr1 and assigned it with the address of x. Again, we declared a double pointer star star ptr2 and assigned it with the address of star ptr1. Now we are printing the value of x with the percentage %d. Here we will get the output as 10. You can see the output screen on the right. The first output is 10. Next, when we want to know the address of the variable x, we'll see this particular string. This is the address of x. Now the same will be stored in pointer 1, ptr1. So the value of ptr1 that we'll get by this percentage %p is the same address of x. Now, if we ask for the address of ptr1, we'll get a different one. We'll get a different address. Address of ptr1 is different from value of ptr1. Now, the same will be the value of ptr2. That is a double pointer. The value of ptr2 here is shown here, which is the same as the address of ptr1. And when you when we print the value of, sorry, the address of PTR2, we'll get a different one. The value of PTR1 and the address of PTR1 are the same, but the address of PTR2 and the value of PTR2 are different. Now, at the end, we are printing the value of PTR1 and PTR2, which is 10. We are printing it with %d at the end. So we are printing the pointers with %p and we are printing the variable with %d. Here this %d and %p are called format specifiers in C. Here at this point, I'll once again explain how the memory is allocated for a pointer and a double pointer. So think of your computer's memory as a giant list of numbered storage locations, each of which can hold a certain amount of data, typically in bytes. Each location has a unique address like a house number. A pointer is a variable whose value is the address of another location in the memory. So instead of holding the data directly, it holds the house number of where the data is stored. In essence, a double pointer is a variable that stores the memory address of another pointer. This might sound a bit mind-bending, so let's break it down with an analogy. Imagine you have a house. The house has an address. Now imagine that you have a piece of paper that has the address of that house written on it. A double pointer is like having a second piece of paper that has the address of the first piece of paper with the house name with the house address written on it. So the first piece of paper is a pointer to the house and the second piece of paper is a double pointer because it points to the pointer that points to the house. Yeah, the double pointer stores the address of the pointer that points to the house or the variable. Working with pointers can be tricky. So here are a few tips. Always initialize pointers. Second tip is always free of the memory that you allocate for dynamic memory allocations. Use tools like Valgrind to detect memory leaks. So that's it for today. We have covered the basics of double pointers and their use cases. In the next video, we'll explore dynamic memory allocation in detail. If you found this helpful, don't forget to like, share, and subscribe. See you later tomorrow. Thank you.